Okay, folks, today we're going to be transforming functions, and we're going to be looking at exponential functions. As you can see in the picture, we have what is called exponential decay, and that is when the b value is a fraction. What's the b value? Well, we'll get to that in a minute, but it's called the base. The exponential growth is going in the opposite direction. It's raising, and the b value is 2 or greater than 1, basically. Okay, let's get started. This is a picture of what it looks like to graph an exponential function using plugging in values. Notice there's a horizontal asymptote, y equals 0, and what's an asymptote? Remember, an asymptote is the invisible line that we make visible. There, it's dashed in green, because the y can never equal 0. If you think about it, no matter how small a number you plug into x, you will never get 0. It will approach 0, but it'll never cross 0. If you plugged in x as 0, you would get 1. Any number to the 0 power is 1, and that is the basic y-intercept for every parent function. This would be considered a parent function, 2 raised to the x power. Any transformation of this function would be a movement or a shifting of that basic graph. So this is the general format. Y equals, or f of x equals a times b raised to the x power. And a is the y-intercept. A will either stretch or compress. And this graph is y equals 2 raised to the x power. The a value is 1. So you can see there, if you plugged in a 0, which is what the y-intercept is, if x is 0, what is y? 2 to the 0 power is 1. So let's do a little transformation here. What if we change the a value to 3? What's going to happen? One of the ways you can do this is always make a little chart. So if we plugged in a negative 1 for x, remember that would make that 1/2. 3 times 1/2 is 3/2. What if x was 0? Well, that would be 3 times 1, and that is the y-intercept. And what if we plugged in a 1? Well, now it would be 3 times 2, which would be 6. So I'm plotting these points as best I can. Remember, all of our functions and transformations that we do are approximate graphs. We are choosing identifiable points. Drawing the line through them, we can see that what happened. The value of the y-intercept moved up, and it also is a stretch. So again, we're just going to continue with this basic parent function so you can see the transformations. Well, what if it's a negative and a 1/2 if the a value? Well, if x is 0, then it would be negative 1/2 times 1, which is negative 1/2, and I've plotted that as best I can. If x is negative 1, if x is 1, then of course we have y being negative 1. And if x was negative 1, that would make the 2 into a 1/2. And we end up, I showed the math there, reminding everybody of multiplying fractions. What if the x is 2 or the x is 3? So we can see that it was compressed, and it was also flipped or reflected over the x-axis. What about horizontal shifts? Well, we can see an h value there. That would be x minus h. Remember, the x minus is still standard. So if I plug in 4, which is a positive 4, hopefully by now, because of the other transformations we've done, you know what way it should go. There's our parent function. And now plugging in values, we end up with those values. If I plug in a 4, 2 to the 0 power is 1. If I plug in a 5, 2 to the first power is 2, and so forth. So I'm plotting these points, drawing my graph, and you can see that it shifted 4 units to the right. So same parent function. What's the shift now? I'm still adding 4, but not to the x, right? I'm adding it to the y. So that is actually our k value. And look at what happens to the asymptote. That's important. The asymptote is actually going to move up to 4. The whole graph gets moved up to 4 units, and it's basically the same graph moved up. So that's the general format with the A, the H, and the K in place. So let's just describe a few transformations. Let's look at that. There's no K value, so it's not going to move up or down. It's got a x plus 5. So let's look. The negative makes it reflect over the x-axis. The 2 makes it stretch by a factor of 2. And the h value is actually a negative 5, because that's the only way that negative x minus becomes plus. So we go left 5 units. Next one. Again, we're reflecting over the x-axis. We are stretching by a factor of 3. We are going to the right, this time 4 units, and down 6 units. Well, that's it. I hope today you're just your beautiful self, and you know you're awesome. Thanks for watching, and you guys have a great day.